My name is Vladimir. I'm working for COMMSEC company based in Moscow, Russia. I'll briefly introduce myself or better our company. Here is just a brief list of our customers, some of them. What we're doing is password cracking and data decryption, mobile forensics and cloud forensics. I will tell about some aspects of cloud forensics we recently discovered. I will start with some information on what data is stored on the smartphones. You probably know, now it's actually much more than probably even on the computer. You have everything in there, including your mails, your data, documents, history. And now mobile devices are being even more widely used for the internet than desktop PCs. And so everything is in there, including the passwords and some other critical data. What our customers from law enforcement are mostly interested in, and how to extract and how to decrypt that information. There are several methods available, and they're all completely different. Probably the best one, if of course it is compatible, is a JTAG or chip-off. When I create a copy of the memory chip of the device, and you have bit-by-bit image, there is quite a lot of problems there. Most of the devices are not vulnerable to that kind of, well, that's not an attack, that's a method. But I have to connect to JTAG debug port, which is available on some of the smartphones. Or you can just take the chip off and insert it into the controller and copy the whole memory. But the problem is that most modern smartphones are using encryption now. For the iPhones, it has started in iPhone 4, and chip-off method is completely useless. For Android phones, the encryption is available since Android version 4.4, I think. It was optional, and it was easily actually crackable because it was based only on the passcode on the device. Starting with Android version 5, the encryption is strong and based also on the hardware key. But still, the attacks for the some Android devices based on some chipsets are still available. Surprisingly, the BlackBerry smartphones, which are considered to be the strongest one, the most safe one, they all can be broken with that method. There is no way to break the passcode on the BlackBerry, but you can just take out the memory chip and copy it. There is also physical extraction method, which also doesn't work on many devices, especially on the modern iPhones. When it doesn't work, the law enforcement goes with logical acquisition, which gets much less information than physical, and also not always available. And the method which is being more and more widely used now is the cloud acquisition. There are several cloud services, and you might be confused with all of them. The device can create a backup to the cloud. Device can sync some information between the device and the cloud storage, or the cloud storage can be used just to store some documents, like in Dropbox or something like that. There are different platforms for Google, Apple, and Microsoft are major players on that market. Speaking of the smartphones, but still there is quite a lot of other cloud services, especially in China. You probably know that Google is prohibited in China, and there are about 20 different manufacturers that are using their own clouds, and they also works their different way. The best thing about the cloud that you don't need access to the physical device itself. You can get everything right from the cloud storage. And sometimes, as we'll show, there is even more information there in the cloud than on the device itself. Extracting backups from the cloud also works, but there is no way to force the device remotely to create backups, and many people don't use cloud backups at all. But still, iCloud backups contain almost the complete data from the device, especially for Apple devices. For Google and Microsoft, there is a different thing. Also, all kind of devices use not only backups, but also some kind of syncing the information between the device and the cloud. And in contrary to backups, where you have to force the creating backups, the syncing is usually being done without any intervention with the user and without any options to set and so on. You just turn it on, set up your account at Google, Apple, or Microsoft, and device immediately starts syncing quite a lot of information. As I said, for Apple devices, backups are probably the most advanced, and they create exactly the same snapshot of the device as for local backups, but those backups do not include the third-party application data. Passwords from different applications, accounts, and so on are not always being saved to the cloud, or if they are, then usually additional encryption is being used, which is stronger than for the rest of the data on the device. Backups are being created daily, usually, at least for Microsoft or for Google and Apple. For Microsoft, we won't able to find any information how the backups are being created. There is no standard way to download smartphone backups from the cloud, and it can be done only using some third-party software. By default, you can only, by design, you can only restore from the cloud backup directly to the device, but that's long, takes quite a lot of time, depends on the connection, and not really safe. And there is no vendor provides any way to manage backup in the cloud. You can only delete the backups you don't need anymore. Speaking of the data that is being synced, we see more and more. It has started with just contacts and calendars several years ago. Now there is much more information stored on the cloud, even if you don't enable backup or set the option to not to create the cloud backups. There are call logs, not only for GSM connections, but also for third-party calling, like voice over IP. There is mail, but not all the mail accounts, of course, but only those that are cloud-based and provided by the vendor. There are media files, there is information on the home devices, there is something about your health data, your internet activities, what websites have you visited, and what you have searched for. For Apple, for example, there is even more, and it is described partially on the Apple website. You can find that information on the Apple website that is dedicated for law enforcement. They describe the process, what information Apple can provide by legal requests, and what is the process, how to obtain that data. And by analyzing that document, you can understand what information, except backups and synced data, is being stored on the Apple services. Here is a kind of comparison of the three major players. Microsoft actually is almost dead, speaking of the smartphones and mobile devices. Windows 10 Mobile is still available, but not being widely used. I think it's less than 1% now. But still, we have explored it a bit. Here is information on backups. Apple creates 3 last backups from the device. Google, there is no such thing as complete backup, unfortunately, and there is only a single snapshot. For Microsoft, there are several snapshots. Maximum we have seen is, I think, 13 different snapshots made in just 2 weeks. Of course, all of them are syncing the contacts and calendars. About call log, that's actually funny. Apple doesn't say anywhere that it's syncing the call log between the device and the cloud, and there is absolutely no way to disable that. Whatever you do, if you have the iCloud account set up on your iPhone, then your call log goes to the iCloud and being stored there, I think now for 2 weeks at least. For Google, we have found that it is also uploading the call log to the Google services about a year ago, and we have implemented the way to download it, but about a month ago it has disappeared. I have no idea why. For Microsoft, call log is stored in the kind of backups that is provided. And here is some information on the other data. For example, for Android, about 2 months ago, we have found a way to extract from the Google account the SMS messages. They're somehow being synced with the Google. That's not for all the devices. That's for most ones who are running Android version 7 and 7.1, but not all of them. Some of the Chinese devices working even on Android 6, if you install the custom firmware, it is uploading the SMS to the Android account, but still, some devices like Nexus 6 don't have the SMS available there. And you have the other data for the internet, for example. Of course, for Apple it is Safari, for Google it is Chrome, for Microsoft it is Edge, and sometimes Internet Explorer as well. Now the most interesting part, the passwords. All three vendors are using different approaches on storing and encrypting this critical data. There are several different passwords to Wi-Fi networks, to websites you enter. The credit card information, I have added it to the passwords category because it is being saved about the same way. There are also application-specific passwords, which are actually much harder to extract. But mostly because the vendors don't follow the suggestions by the developer and don't store the password the right way. Sometimes they're in just some configuration files. So for application-specific passwords, there is no 100% warranty that the passwords are there. There could be also in the cloud storage the encryption keys, certificates, and authentication tokens. For example, if you analyze how Facebook and Twitter and other social networks are saving their credentials into the cloud storage, you will find that the passwords are not there and there is absolutely no way to get them. But on the device and in the cloud backup, there is an authentication token which can be used to access that account and download or just view everything. And there are also autocomplete text that may contain passwords and other critical information. Speaking of Apple, the main storage for the passwords and encryption keys and other data is a Keychain. It has appeared in macOS operating system first, and it works it is about the same in iOS operating system. And there is a difference between how the keychain is encrypted in the local backups and depending on whether backup is password protected or not, and in the iCloud keychain. You can view what passwords and credit cards are stored on your iPhone and are being synced with the cloud by just looking at the options. But there is no way to view the complete data stored in the iOS keychain, and there is no way to export. You can only use the third-party software. For macOS, there is about the same. You can view all the data completely just by entering the password to your system, but there is also no way to export. And for iCloud keychain, there is no way to view or to download at all. All you can do is to sync the iCloud passwords with the device and then view them from the local keychain. There is also a difference between what passwords and what other data is stored in backup keychain and in the iCloud keychain. When we say backup, we mean not only local backup, but also the iCloud backup. But the keychain stored in the iCloud backup is different from the iCloud keychain. It's not, at the first time, not a very easy concept, but still these are completely different things. Keychain and backup is just a file that a part of the backup, and that is being uploaded along with all other files. Here is the content, the part of the content of the keychain from iOS operating system. Here is from Wi-Fi access point, where you have the access point name and password. Here is the password for the email account set at Google, and here is a password to generic IMAP account, which is in fact also Google. You have some additional data like protocol and things like that as well. So speaking of the credit card data, it is also stored in the keychain, in a local keychain, in the keychain which is part of the iCloud backup, and in the iCloud keychain as well. We have the name on the card, the expiration date, the card type, and the number. Why there are different encryptions in the keychain? There are different attributes on the data stored in the keychain, and some of them are being set by the operating system itself. And speaking of the third-party software, the developer himself can decide how he wishes to store that data. If it is completely, I would say, private, he set one of the attributes that includes the, this device only, and then this data can be decrypted only by exactly the same device. And if you restore from backup to the other device, the data will be decrypted there. And that happens, for example, when you restore your iPhone from the iCloud backup, and you find that you have to enter all the passwords to mail accounts, Wi-Fi, and everything else again one more time, because they're not being decrypted on the different device. To get access to the keychain stored in the local backup, you first have to break the password on the backup itself. That was relatively easy in iOS version 3 and became 5 times stronger in iOS version 4, and that lasted for iOS version up to 10. In iOS 10, Apple introduced the, I don't know how to say that, vulnerability or weakness or whatever. And instead of performing the 10,000 iterations of SHA-1, they also managed to store in one other database the single SHA to 256 hash, which is obviously very easy to break at decent speed at millions, tens of millions passwords per second. They reported it back in iOS version 10.1 after we released the software that was able to break the passwords effectively. And in iOS version 10.2, there is actually a nightmare to break the password. The speed on the usual average PC is now only 5 passwords per minute, which is extremely slow, and even on the fast GPU card, we can only get, say, from 50 passwords to maybe 100 passwords per second. And of course, all hashes are salted, and there is no way to create the rainbow tables. Here is how Keychain looks like in macOS operating system. As I said, it's very easy to browse, and once you open any item, you'll have to supply the password, your login password to macOS, and you see the after that you see the password to that data. Now about iCloud data protection. There is an article on Microsoft, and the link is there, that explains briefly, not in details and not technically, how information is encrypted. And it says that it uses advanced encryption standard with 128 or 256-bit keys. It doesn't say anything else, and that's not really good, because speaking of the iCloud backups, it doesn't matter actually how strong your encryption algorithm is, but in the iCloud for backups, the key to decrypt backups are stored along with the data. And so once you've got access to the iCloud and you download all the data, you get the encryption keys, and you decrypt the data stored in backup. But there are still problems. Of course, the iCloud keychain and keychain in general is stored much stronger. I'll explain how. And once the iCloud storage is being accessed by someone else using password or authentication key or authentication token or whatever, the owner of the account immediately receives the notification that his account is being accessed. There are also additional protections starting from two-step verification introduced by Apple, I think 3 years ago or so. The first time it didn't protect backups, but only the sync data. But then after probably Celebgate, you remember that, they also added the two-factor authentication, which is actually stronger. The only way to get access to the iCloud account protected with 2FA is use the authentication token instead of the password. And it is actually faster, easier, it doesn't force any emails or notification coming to the other devices and so on. The question is where to get the token. It's not that hard. You can extract the token from the other device, and best of all from the PC or Mac computer that the same account has been used. Here is a kind of notification. I was trying to download my own backups with our own software just 2 hours ago, and of course I immediately received the notification that my account is being accessed from Netherlands. To set up the iCloud keychain, to have here also not only the general data synced with the cloud, but also your passwords and encryption keys, you have to set up at first. There is a way to do that for the account without two-factor authentication. You'll have to select the security code, and Apple says that it is optional, and you may not to set the security code at all. But in that case, once every new device will be connected to the same account and to be synced, to have the iCloud keychain synced, you will have to manually confirm from the other device. But the profit of using the security code that not only that you can set it up on the other device without the approval, but also if you set the security code, then the iCloud keychain is also uploaded to so-called Apple escrow service and stored in the iCloud. So in the worst case, if you lose everything, all of your devices, including even the phone number, you will be able still to restore that data with the help of Apple. And you can select what security code to use. It can be complex or random, or you can create your own, or you have not to create. But then you got actually you'll get many problems. It's not easy to set up. You'll get many confusing messages. You'll be asked, would you like to use the passcode to your device as your security code, which I don't know whether it is a good idea or not, probably not. And so it's not recommended at all to set up the iCloud keychain without the two-factor authentication. With two-factor authentication, it is much easier. You only have to remember that two-factor authentication can be enabled for the iCloud only from the device itself. You cannot set it up on iCloud.com website. You have to take one of your devices and go to iCloud settings there. And it's then easy. You will have to set up the trusted phone number to receive the SMS, to receive this, the codes by SMS in the case if the trusted device is not available. So it's much easier. Everything is obvious how to set it up, but still, that's probably not the best solution, because the security of the iCloud keychain actually depends on whether two-factor authentication is being used or not. The other thing is, when you set up the new device to the same account with a two-factor authentication enabled, you will also have to enter the passcode of one of your devices, the other device. And that may be the iPhone, iPad, even iPod Touch, or the Mac computer, and you can select what passcode to enter. So yeah, you can see 3 of my devices, iPad and my home Mac and iPhone. That what's happened when I tried to set up the iCloud keychain on the new device. If you want to understand how the iCloud keychain actually works, the good document to start with is the iOS security guide, which has been updated, reflecting the iOS 10 changes only about 2 months ago or so. It's not very technical, speaking of the iCloud keychain, but it describes two main things: how passwords in the iCloud keychain are being synced, and how they can be recovered. Keychain syncing actually relies on the so-called circle of trust. That's not my term, that's a term of Microsoft. Oh, sorry, Apple. And all the devices connected to the iCloud account, and if 2FA is enabled, create a circle of trust. So when any device from that circle can be used to confirm adding the new device to the same circle. And the circle of trust is assigned 2 times, with a public key, which is specific to every device as a syncing identity, and using private key, which is strong and can be broken. It is based on elliptical cryptography with 256 keys, which is even much stronger than advanced encryption standard. And not all the items are being synced with iCloud keychain, but only those that has the COMMSEC attributes synchronizable. And that's why when you set up a new device, set up the iCloud keychain, and still some applications will require you to enter the password once again. There is also very briefly described the method of the keychain recovery in the case if you want to restore to the keychain to the new device. And here the iCloud security code I mentioned before is needed, but it is only needed if the account doesn't have the two-factor authentication enabled. And without that code, you can browse inside go inside the iCloud keychain. It also mentions the hardware security model in the document, saying that everything is stored completely secure. That's not just a simple database, that a special hardware device, and it erases all the content of the device after several unsuccessful attempts. But there is absolutely no information what the device is, and is it real or not? We don't know. There is also a special service established in the iCloud called escrow proxy, which works through the really secure SRP protocol. It is completely safe from the man-in-the-middle attacks, and there is no way to insert your own certificate in the chain and so decrypt the data that is being transferred. The password, of course, also not being transferred and not being saved anywhere on Apple service. There is something like a very basic block scheme of how it works. based on the cloud security code after hashing with SHA algorithms with many iterations, 10,000 to make it harder to break for using brute force. And the keyback key is actually the key to decrypt the keyback itself, and then to using the then the encrypted key is being saved to the escrow proxy established at Apple. The protocol looks like follows. There are not so many commands running there. There is an enroll command to add new records to the keychain. There is a command to get records from there. There is one more which is called get SMS targets, which provides returns the list of all the trusted numbers, and then using the another command generate SMS challenge, you select the number you wish, and you return the SMS code for the next step later. And there is probably the most interesting one is the recover command. That is the second step in the protocol, which actually recovers the data from the iCloud. From the escrow records, which are accessible easier, as I said, with two-factor authentication than for the accounts that don't use it, we can get quite a lot of information on what kind of key is used of protection, number of failed attempts that have been already performed. We also have the data on the trusted devices, including the model version here, for example, MacBook Air with the version and with its name, and the list of the protected storage services available there, because they may be different for different accounts or for different version. There is another slide on how SRP protocol works, and I'm not sure do you see it or not, but I can share the slides with you, and how the device communicates with the iCloud and its relationship with the proxy. And the important thing to know that we can check whether the secure backup records exist, and by existence of that record, we can understand whether the iCloud security code is set in the case of no 2FA, or if it isn't set, then the 2FA is being used on the account. I have only 3 slides left. Probably the most important thing is that if two-factor authentication is enabled, Apple consider that your account is absolutely secure, and keychain data also copied not just across the devices, but also stored in the KVS, which stands for key value storage, and there is a way to get it from there. So here is how keychain recovery works. You have to get account settings first. You supply the Apple ID and password, then you get the first token, then add some data. I omitted the code here, of course, but it's too complex to read. Then you get the token, and using that token, you can perform the sync and initialization and recover commands. But the most important thing that for secure remote protocol, that part, which is very hard to walk around, you will have to confirm the code through SMS, and you will also enter the special cloud security code. But if we already have the two-factor authentication passed, and we have the authentication token for the iCloud, which is normal for accessing the documents, backups, sync data, and whatever, then it's make it much easier to much easier to break into KVS storage and download all the information from there. So what are the alternatives of accessing the keychain this way? There is, of course, you can add a new, for example, fake device to the circle of trust. But that is easy to do from the point of protocol, but you'll have to pass the two-factor authentication, and once you'll try to add the new device, the notification will immediately appear on all the devices connected to the same account. You can download the iCloud backup and get Keychain from there, as far as the iCloud Keychain is synced with the device Keychain. But from the backup Keychain, you won't be able to decrypt the data. That was possible only for all the devices up to iPhone 5 and 5C, which are 30-bit. From there, if you have the device enhanced, it is possible to extract the encryption key, device-specific encryption key from there and decrypt all the records. Or you can get the local backup from the computer that device has been connected to, and if that backup is password protected and password is more or less easy to break, you will be able to browse most of the records from the backup. Oh, finally, there is also a way to break the Circle protocol, but I really doubt that it would be possible. We now have as many as 6 developers working on that, understanding how Circle authentication works and how it is related with key-value storage and two-factor authentication or so for about 4 months, and we have not completed yet. We have found some way to access the data, and now I'm sure that if you have the token from the device authenticated into the iCloud already, it is possible to extract all the data from the iCloud. And if the two-factor authentication is not enabled and the iCloud security code is not set at all, there is absolutely no way to decrypt that data. So that's the very big difference. Thank you. That's it.